Enumeration is a process that's very simple to understand because it's just a way to list whatever is in your network, like all the servers, the workstations, the network devices like routers and switches. You need to know about all the devices that are running in your network in order to be able to scan them for vulnerabilities. And it also just happens that this enumeration phase is the first phase that happens whenever an attacker also tries to discover more information about your network. Alright, so the first step in your vulnerability management process is going to be to list all the systems in your network. And those systems can be servers, workstations, printers, IP cameras, IoT devices maybe, mobile devices, everything that can be connected to the network and can be a security risk. So enumeration basically means just scanning networks and hosts that all belong to some target. Now, if you're an attacker, you want to do this to gather more information, more intelligence, and then use it in your attack strategy. But if you're on the defensive side, you can use the same techniques to identify your attack surface. So where are you the most vulnerable? Where are the places where you have to focus your attention to reduce the number of attack vectors? Most enumeration techniques will involve some sort of active interaction with the target, even if it's something very small, like attempting some TCP connections or a DNS name resolution. And even if some of these techniques don't really make a lot of noise, they can still be discovered if your target knows what to look for. And what I mean by discovered is the fact that the target might figure out that some scanning is happening right now, which might be proof for the first step in a larger attack. And we also have somewhat passive techniques, which are also a type of active scanning, except that their traffic should be indistinguishable from normal traffic that we expect to see in that network. That's because it's almost impossible to figure out that one connection attempt per hour or per day is actually part of a larger attack. It just doesn't look like one. Still, there are such attacks called low and slow or sparse attacks that scan your targets so slowly that any defense security system or security software is simply not able to detect them unless they tune down their sensitivity so much that they will get an enormous amount of false positives, and nobody wants that much work. So these semi-passive scanning techniques are basically going to use the same tools as the active techniques, just that they will scan using a very low scan profile, very slow scan profile. And of course, we also have fully passive techniques which enumerate and scan networks without sending any traffic. Of course, this kind of depends on how lucky you are to just happen to catch relevant traffic and relevant information from that traffic that is just happening to be flowing. Now, of course, intercepting traffic is not so easy because it requires some physical interaction with the network, either by configuring a port mirroring on a switch to duplicate all the traffic on one specific port, or a tap device installed on the network link that again creates a copy of the traffic which you can intercept. One example of passive scanning tools is P0F or POOF, which attempts to intercept TCP connections and look at the TCP flags and headers to determine the version, the operating system, the browser, even the uptime of some devices, again without sending any probes or any synthetic traffic. Another such tool is Zeek, previously called Bro, which also operates as a passive traffic scanner and can also process previously captured PCAP files. Now, just to get rid of this exam terminology here, active scanning techniques can be categorized into two. And the first one is footprinting. This refers to discovering the layout of the network, like the subnets, the IP addresses that you're using, routing, DHCP options perhaps, even routing protocols. So that's footprinting. Then we have fingerprinting, which refers to discovering what is running on a specific host, what ports are open, what version of the operating system might be running in there, any public file shares, for example, anything that can be discovered just by looking from the outside at a specific device. And finally, Nmap, the one thing that you should really know for the exam. This is the Swiss Army knife, the holy grail of network scanning, of host scanning, of enumeration, the #1 tool of every hacker or cybersecurity analyst. Let's dig in. Okay, so assuming that I want to scan my network, I'm going to start small with just one single host first. And I know that one of the hosts in my network is this one right here. 192.168.15.99, and I want to check first if this host is up. So what can I do? Well, I can ping it. Good, we are up and running. But my entire network is a bit bigger than that. Actually, it's something like this. Now, I cannot ping the entire network with a ping command, but I can just try all my hosts one by one. Well, that one is up. This one isn't up, but obviously this is going to take a lot of time because a /24 network means that I have at most 254 hosts in this network. So what can I do to automate this? Well, I could use a script, something like this. It's just one liner here, which iterates through all the hosts from 1 to 254. And now, apart from the fact that this is kind of hard to remember, I can see that it also takes a whole lot of time. 15.1, 15.2, 15.3. Now we're not going to wait for this one to finish. So one of the way I can use Nmap to do this kind of a ping sweep is by using Nmap like this. -s N. So Nmap-SN, you can see here in the middle, basically means do no port scanning. So this is just going to be a ping sweep. So let's see this in action in 3, 2, 1. Sudo password. All right, so much faster this time, like 5 seconds. You see it right here at the bottom. And the results are actually much better than the original ping command. Not only I can see the hosts that are up in my network, but I can also see some of their manufacturers. So I do have some Samsung TVs here, some Amazon Alexas, Raspberry Pi, and some smart home devices in here, and so on and so forth. How does Nmap know this? Well, you probably know about this already, but the MAC addresses actually are made up of 2 parts. The first one is going to be an identifier for the manufacturer, right? There's a universal database for this. You can look it up online, but there are ways to identify to which manufacturer a MAC address actually belongs to. Now, one thing to keep in mind right here is the fact that you will only get to see these MAC addresses if you are in the same subnet or the same network as your target devices. So if you were scanning from outside your local network, outside my home network in this case, then I wouldn't be able to see these MAC addresses here. Hope you know this already. And not only it's fast, but it's also more reliable if you do the scan from within the same subnet. Because if Nmap is connected to the same local network as the targets, then it will also attempt some ARP address resolution protocols and ND sweeps like neighbor discovery protocol in order to find out if a host is up. Usually that's going to be more reliable than just ping, which can be filtered, by host-based firewalls, for example, especially in Windows environments or Mac OS environments. They're going to filter these pings by default, so you're not going to detect those hosts as being up just by pinging them. Okay, so Nmap does have a couple more scanning options. Of course, it's not just a ping sweep utility. Let me clear the screen right here and go into the manual page for Nmap. And if we scroll down just a bit here, after a couple of examples, we're going to find some example scans right here. So first of all, we're going to look at host discovery, and the one that we've just used is -SN, ping scan, which basically means disable port scan. You might be able to find this in older documentation and in older versions of Nmap as -S_P, which was some way of saying scan using ping, but since it's not just using ping, it also uses neighbor discovery, they just removed this option here. It's still going to work, but nowadays it's just called -SN, so make sure you recognize this option in the exam if it comes up. All right, now as far as the scan techniques go, I'm gonna see some examples here. So let's have a look over the scan techniques right here. 2 of them that are going to be of interest for us are going to be TCP SYN and TCP connect options, which are SS and ST. Right now, ST is going to be a TCP connect scan or a full open scan. So we can do it like this. Let's hit enter. Now this was also fast, but you can see now it provides you with a lot more details about this specific host right here, 15.99. I can see all the open ports that I have running in here. This is actually a network attached storage from Synology, and it's running a couple of services. HTTP, HTTPS, print server, file server, a lot of things here. And what it does in the background, it's actually conducting a 3-way handshake. So attempts to complete the TCP connection by asking the operating system to fully connect, just like a normal application, to all these ports that it detects. Right at the end, Nmap is going to send an RST packet, a reset packet, to close this connection. Now, what's a 3-way handshake? I hope you know this already, but just in case you need a refresher, this is what happens. So let's assume that we have Alice and Bob, right? A wants to communicate with B. And the first thing Alice does, because we're talking about TCP, which is a connection-oriented protocol, means that we have to set up the connection first before we send any data. So Alice basically sends a message to Bob saying, "Hi Bob, I want to talk to you, and this is how I'm going to talk to you." All right. Now, Bob, on the other hand, receives the message from Alice and replies saying, "Okay, I also want to talk to you, and this is how I am going to talk to you back. Right? Because we do need a query and response type of communication. We need a bidirectional communication in there. And finally, the third message comes back from Alice as a reply to Bob's request saying just, okay, I'm okay with how you want to communicate with me. So that's basically a three-way handshake. Now, in TCP packets, this is going to be translated in a couple of flags that are set in those initial TCP packets that go between Alice and Bob. Now, Alice sends the first packet and sets the SYN, the synchronization flag, which is basically a way of saying, hi Bob, this is me, Alice, and this is how I want to communicate with you. Now, Bob, on the other hand, sends back a packet which has two flags set. It's also going to have the SYN flag set because Bob is going to initiate a type of communication with Alice as well. So this is Bob's way of saying, hi Alice, this is how I'm going to communicate with you. But it also sets the ACK, the acknowledgement flag, which is a way of saying, I agree with your method of communication. So Bob basically tells Alice, I agree with the way you want to communicate with me. That's through that ACK packet. And finally, Alice needs to confirm Bob's method of communication as well. So the last message is going to come from Alice and is going to set the ACK flag, the acknowledgement flag, saying that, okay, I agree with your method of communication. So that's the three-way handshake. After this handshake, after these three packets are exchanged, the normal data transfer can commence. So that's exactly what Nmap-ST does, right? Finishes the three-way handshake on all these ports, attempts on a bunch of ports here, just to discover which of them answer and which of them are open for communication. This is how we're able to see all these open ports here on our server. Now, by default, Nmap is going to scan about 1,000 well-known or common ports. You can, of course, narrow down the search if you don't want to wait so much. Well, 6 seconds might not be too much, but if you have a larger network, you might incur some delays in here. So you can do something like this. So you can add an option to specifically scan just a couple of ports, which kind of looks like this. With the -p parameter, I can add a list of ports or a range of ports to be scanned. And you can see that the scan has finished in just 0.14 seconds here, and we see those two ports that are really open on the target device. Now, another important type of scanning is the SYN scan, which is possible by using capital S right here. Nmap-S capital S using the same host. Let's try it out. You can see it's a bit faster this time. It's 2.8 seconds instead of 6. And this happens because the SYN scan is actually considered a half-open scan. Now, half-open scan basically means that instead of finalizing the three-way handshake, we're just sending the first SYN, we're getting back the SYN ACK response from the server, and this is faster because instead of finalizing the three-way handshake, what actually happens is Alice sends the SYN packet, Bob replies with the SYN ACK, and then Alice pretends like this never happened, right? And doesn't reply back. So leaves the connection half open, leaves Bob hanging, wondering what he did wrong, where did he miss the Alice opportunity, but Alice doesn't reply back. So basically we're not completing the three-way handshake, thus making the scan run a bit faster, and also, at least theoretically, a little bit more stealthier. And actually, this type of -SS scan is called a stealth scan. Now, remember this for the exam. Right? Remember that this TCP SYN scan is also called a stealth scan, and it's also called a half-open scan. Now, depending on how the target responds to this SYN scan, Nmap can tell you more about that port. Also, this requires more privileges for Nmap to craft those TCP SYN packets, so it doesn't rely on the TCP IP stack of the operating system anymore because the operating system behaves nicely and finishes the three-way handshake. We don't want to finish it right now, so we need admin root privileges for Nmap to run and be able to craft those packages in a non-protocol standard way. Now, this is called a stealth scan, but don't be fooled by this. Any fine-tuned IDS nowadays will immediately detect these scans as well. It might have been stealthy, I don't know, maybe 25 years ago with some very primitive firewalls, but nowadays don't rely on this. It's called a stealth scan. Remember this for the exam, but don't think that in real life it's going to be stealthy. Now, another thing to remember here is that by default, Nmap is actually going to do a stealth scan if you don't provide any additional parameters in here. So if I were to just scan my server here without any other additional parameters, what Nmap is going to do is actually going to be a stealth scan. It doesn't tell you, but that's what it does. and by default it is going to scan 1,000 ports. And you can see we kind of get the same result as before, but since we're in the same network and the servers are replying nicely, we don't see any differences between the stealth scan and the TCP Connect scan. Now there are ways to control the speed of the scan as well. If we go and look inside the manual for Nmap, you're going to find the timing and performance section right here, and it tells you that -T, capital T here, with a value between 0 and 5 sets the timing template. Higher is faster. Now by default it's something around T3, the default scanning speed. So if you want to accelerate your scans, you can do something like this. So let's go back to our network scan, like this ping scan right here. And let's make it a T0, low and slow. I'm gonna see it's gonna take a lot of time now. This is useful because by going low and slow, you do have some chance of evading some specific IDS policies and some IDS rules that might be able to detect your scan. If you go just slow enough, they're not going to detect you, right? They're not going to figure out that all those packets sent over the length of an hour, for example, belong to the same scanning process. Now, it's gonna take a lot of time here, absolutely, so I'm gonna cancel this one out, but let's try it with a T5. And there you have it, scanning the entire network in less than 3 seconds. That's gonna a lot of scanning traffic, that's gonna be noisy, but it's gonna provide you with the results much faster. Some other scanning techniques that you need to know about, at least for the exam, are the scanning techniques that set specific flags in your TCP connections. So for example, you can do a TCP null scan which sets no flags and just see how the firewall reacts to those. A FIN scan which forces the closure of a TCP session, even if the session wasn't initiated to begin with. And the Christmas scan here actually means that the flags of FIN, push, and urgent are all set and kind of light up the TCP packet like a Christmas tree, right? That's why it's called the Christmas scan. Now, these are weirder scan methods, but can confuse some older or very, very basic firewalls. Fast mode, capital F, is to scan fewer ports than default scan. Another one good to know for the exam. Don't forget about the port ranges scan, which we just seen before. You can specify one single port here, or a range, or just each port in turn separated by commas. You can also combine it with ranges as well. Traceroute can be added to Nmap. You don't have to use traceroute by itself to display all the hops, the layer 3 hops that are between you and the target. And we've been talking about TCP, but of course we can also do a UDP scan. Now, since UDP doesn't acknowledge packets, you knew that already, right? It's not connection oriented. We don't have a three-way handshake. Now, this type of scan kind of depends on the application that's being scanned, and Nmap can only wait for a couple of seconds for a response from that application, and it can take a long time because it has no way of receiving an acknowledgement. It just has to wait to see if that application sends something on that port. So it takes a lot of time to scan using UDP ports, but if you do have to use it, you have the option here in Nmap as well. Finally, another type of scanning that's very useful to know for the exam are actually two flags here. The first one is -D, which uses a decoy, and actually a very similar one is this one right here, -S capital I. That's a zombie host, basically also a decoy, also known as an idle scan. And that's a way of doing a stealth scan where another host, also known as a zombie or a decoy, appears to be doing the scanning so that you don't show your true IP identity. Very important for the exam. I can guarantee that you'll be asked about this. And since we're talking about firewall and IDS evasion here, you can also find this option useful as well. Spoof the source address. Basically send your packets, send your scanning packets with another changed spoofed IP address as a source. -F or --MTU allows you to scan using fragmented packets. Now, fragmented attacks have been for some time a special attack technique because they were either ignored, which allow you to bypass the firewall, or they could be used for a denial of service attack, since reconstructing the original packet from multiple fragments takes up router or firewall memory. So not so useful nowadays, unfortunately. or fortunately. Why did I say unfortunately? Because we have some powerful devices nowadays which aren't fooled so easily and don't have their resources so easily eaten up by these fragmented packets. Alright, so we know how to scan for open ports, we know what services are running on our devices. Let's see if we can get some more information, right? Because I know what devices I have running in my network, I know what ports I have open in my network, but what exactly is running on those ports? Because just by looking at the port number might not be exactly the necessary giveaway that I need in order to deduce what kind of service is running in there. So you have different types of scanning options with Nmap for this as well. So if we scroll down here in the man page, I'm going to find another section here about OS detection. Capital O, enable OS detection. Let's try this one in our network right now. So sudo nmap and add my entire network in here. Let's give it a few seconds to run and see what happens. Now this is going to take a bit more time here, and if you're not sure if it's still running, you can just press enter from time to time, and it's going to tell you how much has elapsed, how many hosts have been completed, how much time we have remaining. So about 1 minute. Don't worry, I'll fast forward. Alright, scan done. Let's see what we have running in our network here. Now, the last one here was Harmony Hub from Logitech. So this one actually runs a type of Linux 2.6. You didn't know that, right? Let's see what else we have here. A Raspberry Pi, of course it's running Linux. This is my smart vacuum cleaner, which apparently also is running a Linux version here and has an SSH port open. That's interesting. We also have an Amazon Echo here. This is the Alexa, which runs Google Android.
I didn't get that.
All right. I know you didn't get that. Okay, this is my network attached storage from Synology here, which also runs a Linux operating system. A Samsung TV here doesn't behave very nicely. It says too many fingerprints match this host to give specific OS details. So OS scanning provides you with a lot of details about the operating systems that are running on these hosts. Now there is one more level we can go to, and that is try to determine what services are actually running on these operating systems. Have a different set of options for this, which is the service and version detection, right? Probe open ports to determine service and version information. -S, capital V. Now there's a way to combine these two, which is by using a capital A. You can see it right here. Enable OS detection, version detection, script scanning, trace route. So basically throw everything but the kitchen sink to that device and try to find out as much as possible about it. Right, so let's try doing this on our server right here, because if we do it on the entire network, that's going to take quite a long time. So I'm going to use the -A parameter here. Now, while this scanning is running, let me tell you that the results here are going to include the actual protocol that's running on the port, so we can see that's already done here. So you can see the results include the actual applications that are running now on these ports. All right, so for example, for AFP, we have Netatalk. For Samba, we have SMB version 3 or 4, right? We don't know exactly which version that is. I have a web server here on 443 that's running over Nginx. We also have multiple ports open here, starting from ports 5000 through 5001, 7000, 8000, and so on, and they are all running on Nginx. This is how you can determine that there's an actual web server running in there, even though it's not running on the standard ports for HTTP like 80 or 443. So that's protocol version scans, right? Remember -S capital V or -A. One thing to mention here is the fact that you also get the CPE listing for all these devices. Remember this common platform enumeration? So this is a way of describing the platform that is actually running in there. So what type of device is it? Is it a smart home device, a printer, an Xbox, a mobile phone, anything like this? If it can be identified by Nmap, then it's going to tell you the exact CPE code for it. Now, another way to find out about the scanning methods and the best practices in Nmap is to actually use their official documentation here on nmap.org. They're going to provide you with a lot more explanation here about all these scanning techniques, what they do, when they can be detected, how can they be detected, and so on. So have a look over the official Nmap website here for more information about additional types of scan. Now, Nmap can also be extended by using some specific scripts, and those scripts are part of what's called the Nmap scripting engine. So you can basically use some scripts here to do some more advanced types of scanning, or to combine multiple ways of scanning, including application level scanning. So you can have some scripts, for example, that look for specific web application vulnerabilities or other types of vulnerabilities in other services, which go a bit beyond Nmap's usual scanning techniques. So we can actually use Nmap for vulnerability scanning. We can either specify the exact script that we want to run here, or just run all the vulnerability scripts at the same time. This is going to take some time here, so I'm going to fast forward this to the results. And we're going to end up with something like this. As you can see here, the scan took almost 10 minutes here. Did take some time here to run all these vulnerability scripts, but it did find a lot of vulnerabilities on my home router here. You can also see the CVE identifier. So this one is vulnerable to a slow low-risk denial of service attack. It also gives you a nice explanation here about this type of attack, when it was disclosed. That's a bit worrisome that it hasn't been fixed just yet. Another one also vulnerable for a slow low-risk denial of service attack in here. Also get the link for the CVE under the MITRE's website, as we've seen in our previous episodes. So you can also use Nmap as a very basic vulnerability scanning tool. It's free. It's completely open. Use it if you don't have anything else in your environment, but there are definitely better tools out there. Right, so after the scan, Nmap will return some results that describe the port states. Now, we have reliable states, when Nmap can be pretty confident, like open, just what it says, it's open, it's reachable, awaiting connections. Closed, that's when the port responds with reset packets and there's no application accepting connections in there. It might be, for example, closed because it's not open on the device, or a firewall is dropping the connections. And filtered, that's when the port cannot be probed, usually due to a firewall in between. Now, the other port states are used when a firewall isn't really friendly to the outside world and doesn't supply enough information for Nmap to confidently determine the port state. So, for example, unfiltered, which means it cannot determine if it's open or closed, but it's reachable. This is normally generated by an ACK scan, an acknowledgement scan, which is used to just map out firewall rules. But since an ACK scan cannot initiate a connection, it cannot determine whether the port is open or closed. Now, open or filtered, again, cannot be determined due to a limited scan, like a UDP scan, for example, where the device doesn't reply with anything. Closed or filtered is again undetermined, and this is generated by idle scans or decoy scans. That's a completely stealthy type of scan that uses a decoy host and IP spoofing to send scanning packets, and relies on probing that decoy's IP packet numbering to determine if a response is received. Pretty smart technique, but doesn't always work. Another important utility here is Hping, which is kind of the younger brother of Nmap. It's more than an advanced ping utility, actually. That's a true understatement. It's a very powerful packet crafting and packet spoofing utility, which is great for reconnaissance. Now, in the command line, you're going to find hping as the hping3 command. You can add a -age parameter at the end to just list the possible options here in a very brief format. So, for example, we can see how to set specific TCP flags here at the bottom, how to do an ICMP scan, which is not very intuitive here. A -1 means ICMP, a -2 means UDP, so it has nothing to do with IP protocol numbers, for example. Right, so let's try doing a SYN scan on a port on our victim server in our network, which is going to be hping3 followed by a S, capital S for a SYN scan, port number 80, a count of 1, so I'm only going to attempt one single connection here, and press enter. Right, you can see that it also provides you with some information here about the IP packet that was generated, like the TTL, the flags, do not fragment flag here, source port, destination port, window size, round trip time, a lot of useful information here. And you can see that we did receive one packet in return, which means that the port is open. We can also do an ACK scan, that is sending packets that don't have the SYN flag set, just the acknowledgement flag set. We can also do this with Nmap as well. And the behavior we expect to see with an ACK scan, and remember this for the exam as well, is to receive a reset back if the port is open. So the port is answering, it's just that we're not sending the right first packet in order to create that three-way handshake. We're not sending a SYN packet, we're sending an ACK packet, and the port replies to us, no, that's not how you start a conversation. So let's try this one with an ACK scan here. You can see we do receive a response here, but the flags that we receive and return is a reset flag, just like we expected it to. And this tells us that the port is open. Now we can also try getting the system timestamp from a device. Let's see how long this device has been connected to the network. You can add the --TCP timestamp flag in here, and apparently my home server here has been up for 35 days. That's a pretty useful piece of information that you can get simply by being in the same network as your target. Now Hping can do so much more. It can be used to generate fragmented packets, to perform attacks like ping of death, or even denial of service attacks. Now a lot of these older attacks don't work anymore on modern operating systems, but thanks to IoT devices and how oblivious many of them are about security, you might just get lucky. Or not, depending on which side you're on. Now finally, one last tool here is called Responder, which is basically some sort of a man-in-the-middle tool, but a more specialized one, because it's a tool to help you determine if you are vulnerable to LLMNR, that's link local multicast name resolution attacks. Usually happens if Windows falls back to another type of name resolution. So if DNS fails, then it falls back to LLMNR, and then it falls back to NetBIOS, depending on your Windows configuration. And of course, it can intercept those requests and inject some spoofed responses. Now, Responder can intercept those requests and inject spoofed responses, just to check if you are vulnerable or not to this type of attack. Check this link right here for more information. Just remember about this tool, what it does, generally for the exam, and you should be good to go. Right, so for the exam, make sure you are familiar with the reconnaissance tool that we've covered here, like Nmap and Hping. Make sure you understand the difference between active and passive reconnaissance, and also the difference between fingerprinting and footprinting. But before any of that, make sure you master the scanning options for Nmap and Hping. The exam is most definitely going to ask you about those. So good luck on the exam. Thank you for watching. Don't forget to like and subscribe, and see you on the next video.